that cheesy intro, but plants do love the sun, and I'm sure you've seen them turning towards it. This process actually has a name, phototropism, from the Greek words for turning towards the light. It's around 1880. Renowned scientist Charles Darwin and his son Francis plant a seed which sprouts out a coleoptile. Charles and Francis put a black cap over the tip of the coleoptile. The plant would not bend towards the sun. What was going on? The coleoptile's tip was somehow sensing the presence of sunlight and communicating it to the growth zone. The growth zone, when it received the message from the tip, bent over towards the sun. But what kind of message was the plant sending? A few decades later, Danish researcher Peter Boysen Jensen uncovered the identity of the mysterious thing being sent down from the tip of the coleoptile. He did this through a very interesting experiment involving gelatin! Peter cut off the tip of the coleoptile off with his head and put a piece of gelatin on what remained of the plant. Then, he replaced the tip of the coleoptile so that the gelatin separated it from the other part of the plant. The plant still grew, even turning toward the light. In 1926, Dutch biologist Fritz Wendt discovered the enigmatic stuff that came down from the tip of the coleoptile was a chemical. Fritz named that chemical auxin, from the Greek word for grow. Not oxen like cows. Anyway, before I tell you about this marvelous stuff called auxin, you have to understand how a plant cell works. Plant cells are like slinkies. They grow by elongation. Now, imagine that these slinkies are the cells in a coleoptile, and these marbles represent auxin. When the tip of the coleoptile lets out auxin, the auxin flows down to the cells, causing them to stretch out. But now, let's say the sun is shining on the right side of the coleoptile. The plant's light receptors on the right side redistribute the auxin to the left side. The auxin, when it reaches the cells on the left side, causes pumps to be activated. These pumps shoot out hydrogen ions. The ions hit the cell walls, and they put enzymes into action. Because the walls are broken by the enzymes, the cells become softer and more flexible. Therefore, the cells on the left side are stretchier than the cells on the right side, and so, when the coleoptile grows, it bends toward the sun. And that, my friends, is exactly how phototropism works. Auxin!